Let's have a look at the geometric features of special quadrilaterals. Now, what do I mean by special? Well, a square, rhombus, rectangle, parallelogram, trapezium, or kite have special features, which I've listed here, which distinguishes them and makes them quite recognisable, as opposed to any old quadrilateral, which is just any shape that has four sides. So going through these one at a time, pairs of equal opposite angles. Now let's just have a look at what the square has. Pairs of equal opposite angles, we'll start by drawing the square and thinking about what symbols it needs. We know the square has right angles in the corners and its sides are equal, so we give each of them a dash. And it has this side parallel to this one, so we give them an arrow, and this side parallel to this one, so you give them two arrows. And that's pretty well it. So pairs of equal opposite angles, yes, it has two of those. Pairs of equal opposite sides, two. Diagonals are equal length, yes, two. Pairs of parallel sides, two. All angles equal, yes, they're all 90 degrees, yes. All sides equal, yes. Pairs of adjacent equal sides, well, yes, adjacent means next to, so this side is equal to this one, and this is equal to this one's equal to this one, and this one's equal to this one. So you could sort of say there's four there. You could also just say all. And the diagonals, do they bisect the angles that they pass through? Yes, they do. This diagonal cuts this angle into two equal angles. So we'd say yes, both. Or you could just say two there, I suppose. It has two that do that. All right, comparing this now to, we might cut to a rectangle, because a rectangle is very similar, except of course it's just longer in one direction. Now a rectangle will still have all angles equal. It has two pairs of parallel sides, and it has this side equal to this one and this one equal to this one. What it doesn't have is it doesn't have its diagonals bisecting this angle. We get a small angle here and a big one here. So it doesn't meet this, no. Other than that, pairs of adjacent equal sides, no, it has none. All sides equal, no. All angles equal, yes. Pairs of parallel sides, it has two. Diagonals of equal length, two. Two pairs of equal opposite sides, and two pairs of equal opposite angles. Okay, now a rhombus you can remember as a square that's been sort of pushed over or tipped a bit on its side, whereas a parallelogram is like a rectangle that's been pushed over or tipped a little bit on its side. So, drawing a rhombus first. A rhombus has all of its sides equal. All sides equal, yes. It does not have all angles equal though. It has two small angles and two big angles, but it does have two pairs of equal opposite angles. Pairs of equal opposite sides, well yes, all the sides are the same. Diagonals of equal length, no. One's long and one's short. So, none. Pairs of parallel sides, it has two. All the angles being equal, no, we have two big angles and two small angles. So that's a no. Pairs of adjacent equal sides, well, yes, all of them, because they're all equal. And do the diagonals bisect the angles they pass through? Yes, they do. So this angle and this angle would be the same, and this angle and this angle would be the same. Another feature that we haven't put on here is the diagonals actually meet at right angles. So all of these here are right angles. And that is true for, so let's add that to the list. Diagonals meet at right angles. And that holds true for a square and a rhombus and a kite, but none of the others. Okay, so a parallelogram is a lot like a rectangle, but it's been tipped on its side. So it looks a little bit like a rhombus too, doesn't it? But it's longer and thinner. So this side's equal to this one's equal to this one. And we've got two pairs of parallel sides as well. But we're going to get a long and a short diagonal. The diagonals are not going to meet at right angles. And they're not going to bisect the angles that they pass through. So as we look at what the parallelogram has, two pairs of opposite angles, two pairs of opposite sides, Diagonals are not equal length. No. Pairs of parallel sides 2. All angles equal? No. All sides equal? No. Pairs of adjacent equal sides? No. The diagonals bisect angles? No and no. Okay, so that's those 4 that are sort of based on a square, rectangle, or square or rectangle that's either upright or pushed on its side. A trapezium just has, let's draw it a little bit bigger. A trapezium just has 2 sides that are parallel, and then the other 2 sides are just randomly whatever. Okay, they're not the same length, the angles aren't equal, it has nothing else much going for it apart from these 2 parallel lines. So pairs of parallel sides, it has 1 pair of parallel sides. Other than that, it doesn't have any of these other features. It doesn't have any of these, and no, the diagonals could be anything at all. So it hasn't got much to remember really, the trapezium, except for the fact that it has got 1 pair of parallel sides. Now the kite is an interesting one. This side and this side are the same, and these 2 sides are the same length. So it doesn't have any opposite sides, but it does have 2 pairs of adjacent equal sides. The diagonals are different lengths, one's long and one's short, but they do meet at right angles, which we've already put in there. Now, one of them bisects the angles it passes through, so these 2 angles would be the same, and these 2 angles would be the same, but these 2 you'd get a big one and a little one. So when we say here the diagonals bisect the angles they pass through, only one of them does. Other than that, all sides equal, no. All angles equal, no. It has no parallel sides. Diagonals are not equal length. And pairs of equal opposite angles, well, this angle is equal to this one, but these 2 are going to be different, aren't they? One will be bigger and one will be smaller. So it has 1 pair of equal opposite angles. And that chart should help give you something of a summary. It's important for all of these special quadrilaterals to be able to draw the symbols on, showing what the features are. And that should help when you're dealing with quadrilaterals and trying to find missing angles, because if you know which angles need to be the same, then if you know one, you'll know another.